Here is a CBSE board exam question that appeared in 2022, and this involves resistance and resistivity. Before we look at this question, let us look at the formula for resistance of a wire. So here I have a wire made up of some material of resistivity rho. It has uniform cross-section area A. Current enters this way and exits that way. The length of the wire is L. Then the resistance of the wire is given by rho L by A, where rho is the resistivity of the material, L is the length of this wire, A is the area of cross-section. So resistance R is rho L by A. So we know this formula, and we are going to use this formula to solve this question. Okay, let us read this question. An electric current is passed through a circuit containing two wires of the same material. Same material means same resistivity. But the length of the wire may be different, the area of cross sections may be different, so therefore the resistance of each of those wires will be different, but they are made up of the same material, so therefore resistivity is the same. These wires, they are connected in parallel. If the lengths and radii of the wires are in the ratio 3:2 and 2:3, what does that mean? Lengths are in the ratio 3:2, so the lengths are different. Radii, they are in the ratio 2:3, again radii are different. So obviously that means the resistances will be different, and we want to find the ratio of the currents passing through the wires. Now remember, both the wires are connected in parallel, so that means the potential drop across the wire will be the same for both the wires, but the resistances will be different, and so once I find the ratio of the resistances, I can use that to find the ratio of the currents. Okay, so we know R is rho L by A, right? Resistance of a wire is given by rho L by A. Now here we are talking about radii, that means you are talking about circular cross section, so area of cross section will be pi r square. So if I think of it as pi r square, so that means R, the resistance, is proportional to length by R square. R is proportional to length by R square. Okay, so what does that mean? That means if I look at R1 by R2 for two different wires, it will be L1 by R1 square divided by L2 by R2 square. R1 and R2, where I am using small letters R, this basically talks about the radius of the cross section area, whereas capital R stands for the resistance of that material. Okay, so what is this? L1 by L2, and then this is going to basically, right, you have to take the reciprocal, so you have to write R2 square by R1 square. So L1 by L2 into R2 square by R1 square. Now L1 by L2, the ratio of the lengths is 3 by 2, right? 3:2. R1 by R2 is 2 by 3. R1 by R2 is 2 by 3. This is R2 by R1 whole square. So it will be again 3 by 2 whole square. So L1 by L2 is 3 by 2. R2 by R1 is 1 by R1 by R2. R1 by R2 is 2 by 3. So R2 by R1 is 3 by 2. So 3 by 2 whole square, because there is a square there, there is a square here. 3 by 2 whole square. So this is going to give us 9 into 3, 27 by 4 into 2, 8. So basically 27 by 8. So the ratio of the resistances is 27 by 8. One wire has 27 by 8 times another wire's resistance. That's what we have here. So can we say that the currents will be in the same ratio? Let us think. Okay, so this is R1 by R2. So we have to write the answer in R1 by R2 kind of a form, right? The first one to the second one. That's why the length ratio is given 3:2, radii ratio is given 2:3. So I'm saying the first one to the second one, ratio of the resistances is 27:8. But let us think about it. In parallel connection, the voltage across both the wires is the same. So that means both have the same potential drop. The resistances are different. So what about the currents? So current 1 will be V by R1, current 2 will be V by R2. So I1 by I2, right? Ratio of the currents is asked. I1 by I2, well, just think about it. I1 by I2 will be R2 by R1. I1 by I2 will be R2 by R1. So R2 by R1 will be the reciprocal of this. So it will be 8 by 27. So therefore the answer to this question is the ratio of the currents will be 8:27. 8:27. So if the ratio that was given is 3:2 and 2:3, right? The first one to the second one is 3:2. First one to second one radius ratio is 2:3. Then first one, second one ratio of currents will be 8:27.